All right, guys, welcome to lesson 4. We've looked at the 3 factors that affect engagement, student-driven pacing, and then how to use class time. All of those things are great, but we also sometimes run into situations where our kids just don't understand chemistry and don't understand what we're saying, and that's where this lesson comes into play, by helping our students to speak chemistry. So, have you ever been to a foreign country? This is a picture of when I lived in Croatia for a year. That's in former Yugoslavia, just on the other side of the Adriatic from Italy. And so I lived there for a year. And thankfully, I lived in a touristy city where a lot of people spoke English. But I had to pick up some Croatian along the way. Have you ever been around a pair of native speakers and they're having a conversation and they're just like, and you're like picking out one word out of 20 maybe, because they're speaking in foreign language. And I think sometimes our kids can feel this way in chemistry class, especially when we throw out terms like nomenclature, polyatomic ions, limiting reactants, percent yield. And they're like, what? And so we need to either figure out some way to help them understand what those terms mean along the ways. Part of this can be pacing. Like if you're trying to learn a new language and the native speaker is speaking fast, it makes it so much harder than if they slow down and allow you to hear one word after the next. And so sometimes pacing can be what solves this, and that's where student-driven pacing comes in, okay, like I said. Or it can be communication issues. The way we are communicating it to our students just doesn't work. So we've got to come out to something. So first step is relating to prior knowledge. What do they already know? What things do they know? It could be something within chemistry. Like, hey guys, remember when we talked about this thing back here? Ah, yes, okay. And then you can connect it. I taught Algebra 2 and pre-calculus a lot of times. And so there's a thing in Algebra 2 and pre-calculus called rational expressions, where you take x squared plus 4x plus 4, and you put that inside of a fraction. You got one of those on top, one of those on bottom, you got polynomial on top, polynomial on bottom, plus, minus, multiply, divide, doing math with fractions with polynomials in it. And it's nasty. And it's really, really hard for kids. But I always take a day beforehand to go over basic rules of math with fractions. And so I get them like, hey, 1/3 plus 1/4, do the math. And we practice doing that. What I'm trying to do is I'm trying to reactivate that prior knowledge that they have of fractions before I add this crazy algebra on top of it. And so the same thing happens with chemistry, that we're bringing those things in. We're tying to what they already know. That stoichiometry is building on moles. So make that blatantly obvious for them, because they probably won't make the connection. So it's important that you make the connection for them. Okay. All right. Use illustrations. So I've got a fox here because that's one of my illustrations I use. So when I'm talking about ionization energy, and I say, which one would be easiest? A big atom with an electron way out here, or a small atom with an electron down here. And the way I explain it, it's like, all right, guys, if that nucleus was a farmer with a shotgun guarding his chicken yard, let's just say he had a round chicken yard, would it be easier to take an electron or a chicken, if you're a fox, is it easier to take a chicken from a chicken yard where it's here and the farmer's in the middle, or a chicken yard that's like this and the farmer's in the middle? And they're like, oh, big one. I'm like, exactly. And so it's the same thing with ionization energy. It's easier to pull this one off than it is to pull one closer. The other one I use with ionization energy is I say, all right, guys, how much energy would it take you to go to the movies as your parents say, hey, here's $20, go to the movies, have fun with your friends? And they're like, none at all. I'm like, how much energy would it take for your parents to say, hey, we want you to take out the garbage, empty the dishwasher, clean your room, all those things? And they're like, oh, that would take way too much energy. I'm like, exactly. When you want to do something, it doesn't take much energy. And so when an atom wants to give away an electron, like a sodium, then it's easy. But something like a chlorine's like giving away an atom's like asking them to do chores. And they're like, no, thank you. And they're going to hold on to it. Or like I like grilled cheese sandwiches, one that I use a lot. I use this one for limiting reactants. I'll say, all right, guys, you got 10 pieces of bread and 8 slices of cheese. How many grilled cheese sandwiches can you make? And I'll have to specify 1 slice of cheese per sandwich. Otherwise, I got those kids who always do 2. I'm like, all right, 1 slice per sandwich. How many sandwiches can you make? And they can figure it out because it's prior knowledge. And I'm like, hey, well, what happened? Well, we ran out of bread, so we couldn't make any more sandwiches. I'm like, exactly. All right, well, what are we making an equation? I say 2 bread or 2B plus 1C equals, yields 1S. 2 pieces of bread plus 1 piece of cheese gives me 1 sandwich. And then I'm like, all right, so let's kind of look at this like a reaction. And then I teach limiting reactants out of that. Now I'll do the same thing with percent yield with cookies. I'll be like, hey, my recipe says I can make 3 dozen cookies. I only made 28. What yield did I get? What percent of those cookies was I actually able to make? And then I teach them actual yield, theoretical yield, and percent yield using chocolate chip cookies. That way they have something mental to hang their hat on when I add the chemistry. That's so much of helping these kids teach chemistry, speak chemistry, is you're giving them categories or terms or an illustration or some other knowledge to hang new knowledge on. Otherwise, there's nowhere for it to go and it just falls through the cracks. And so that's kind of our job as teachers, is to help them with this. And so that's why I think it's so important. So once again, make any connections to prior knowledge explicit, because kids are going to miss it. What is obvious to you is not obvious to them. So any connections, make them as explicit as possible. Okay? I'm like, hey, grilled cheese sandwich equals limiting reactant. That's not a good connection. I need to be much more explicit about that. All right, action step. Decide on at least 2 ways that you can use illustrations or prior knowledge in your next lesson. Okay? Trying to help kids connect to what you're saying with what they already know. Find 2 ways to give them hooks to hang on to in your next lesson. All right, this is critical, because once again, that confusion piece is the enemy of engagement. And so if you can work to avoid that confusion by giving them things to hang the information on, you make your life a whole lot easier. All right, so that's lesson 4. Look forward to seeing you in lesson 5.